All right, this is the sample test to the Chapter 8 test on sequences series and the binomial theorem for functions trig. On this test, we've got two parts. This first part on here is the no calculator part, and then we'll switch over to a calculator part in just a minute. This is the formula sheet for this unit. It has the formulas for the arithmetic sequence up here at the top, then the geometric sequence, then the arithmetic series sum, and the geometric series sum. And then if I scroll down a little more there on the bottom, we've got the sum of an infinite geometric series, and this only works if a common ratio is a number between -1 and 1. All right, so these formula sheets will be provided. I'll reference it throughout the test, but you will get this when you're taking your test. Okay, back to the start on number 1, it says show that you know the meaning of an arithmetic sequence. So arithmetic and sequence by writing the next two terms of this arithmetic sequence. Well, we recognize it's a sequence because there are commas in between the terms, so that's good. And then in order for it to be arithmetic, we have to have a common difference every time. Well, in this case, to get from 30 to 10, I would have decreased by 20. So if I'm arithmetic, I will continue to decrease by 20 each time. And 10 minus 20 is -10. If I subtract another 20, I'm at -30, and that would make this arithmetic. Question number 2 says show that you know the meaning of a geometric sequence by writing the next two terms of this geometric sequence. Again, it has commas, which means it's a sequence. And then when you look at it to start off, the first two terms are exactly the same. So we've got to recognize that in order to be geometric, I have to multiply by a common ratio every time. So 30 times the common ratio has to equal 10. So in other words, what you multiplied 30 by to get 10 was 10/30ths, which reduces to 1/3. So what we multiply by every time is 1/3 to get the next term. If I do 10 times 1/3, that will give me 10/3. If I do 10/3 times 1/3, that will give me 10/9. And this would make a geometric sequence. All right, on number 3, it says, so that you know the difference between a sequence and a series by writing the first 3 terms of a geometric sequence and a geometric series, each of which has a first term of 5 and a common ratio of 3. So this is a lot of information here, but either way, we see that this first term has to be 5. So whether we're talking about a sequence or a series, the first term is 5. In order to be a sequence, that means I need to have a comma before I get to my next term. Whereas if I were down here in the series, I would have 5 plus whatever my next term is. Okay, so now we have to actually get to the next term. Well, I said that the common ratio is 3. That means R is 3, or every time we're going to multiply by 3 to get the next term. If I take 5 times 3, that's 15. So the next term of the sequence would be 15. That's also the next term of the series, but again, the series is separated by addition, whereas the sequence is separated by commas. I'm supposed to list the first 3 terms, so I need to do this one more time. If I take 15 times 3, that gives me 45. And I can add that also to my series list. You must recognize the difference between a sequence and a series, and you have to read the directions to see that we need to write 3 terms and need to make it geometric. Question number 4 says, show that this sequence is neither arithmetic nor geometric. Well, let's start out with arithmetic. If it were arithmetic, then I went 2, 6, 12. In order to be arithmetic, I need to have a common difference every time. In my first term, to get from 2 to 6, I'm adding 4. To get from 6 to 12, I'm adding 6. So this is not arithmetic because there is no common difference. All right, we also have to check that this is not geometric. Again, I have 2, 6, and 12. In order to be geometric, I have to multiply by the same thing every time to get the next term. 2 times 3 would give me 6. Well, 6 times 2 gives me 12. So that means this is not geometric because I can't have 2 different common ratios. It's not a common ratio. Number 5 asks me to evaluate and simplify. It says S sub 4. That means the sum of 4 terms, and then it gives me this sigma notation right here. Remember, with the sigma notation, on the bottom is going to be the first thing you plug in. Over here on the right is the formula, and that has to be an explicit formula. We'll never write this recursively. And on the top is the last thing you plug in. All right, so let's do this problem. The first thing I'm going to plug in is k equals 1. If I plug in k equals 1, I have 1 squared plus 1, which would be equal to 2. Next thing I'm going to do is I'm going to increase that. So now I'm going to plug in 2. If I plug in 2, I'll have 2 squared plus 1, which would be equal to 5. Then I'm going to plug in a 3. So I'll have 3 squared plus 1, which is equal to 10. The next thing I'm going to plug in is a 4. Notice 4 is the number on the top, so that's the last thing I'm going to plug in. I do 4 squared plus 1, so that's 16 plus 1, which is 17. So I've just expanded each of the terms, but because this is a series, that means I need to add all of these numbers together. So I have 2 plus 5 is 7, plus 10 is 17, plus another 17 is equal to 34, and that's the sum of my series. Number 6 asks me to write the next 2 terms of this series, so I have to figure out what's the pattern. I always start out looking for an addition pattern, because that's easier to me. If I were looking for an addition pattern, I would say 2 plus 4 is 6, but then I say 6 plus 6 is 12, so it doesn't look like it's addition to me. Next thing I would check is maybe could this be a multiplication pattern? Well, 2 times 3 gives me 6, but 6 times 2 gives me 12. So it doesn't appear right now that I'm either arithmetic or geometric. I'm going to have to see if another pattern develops. If I continued this multiplication pattern, 12 times what gives me 20, this does not look like it's going that way. But if I look back at my addition problem, I started out with 2 plus 4 gave me 6. Then 6 plus 6 gave me 12. 12 plus 8 gives me 20. 20 plus 10 gives me 30. 30 plus 12 gives me 42. So this is not a straight arithmetic, but what I notice is the terms that I'm adding form an arithmetic sequence. I add 2 more each time. So to get from 42 to the next term, I would need to add 14, which would make this 56. To get to the next term, I would need to add 16, which would give me 72. Number 7 reads, the first and fourth terms of an arithmetic sequence are, respectively, 15 and 27. And you can see that's what I've written out for you here. This is the first term, this is the fourth term, so there would be 2 terms in between, and this has to make an arithmetic sequence. I'm supposed to write the second and the third terms. If this is arithmetic, that means to get from 15 to the next term, I'd add d. Then to get to the next term, I'd add d again. And finally, to get to 27, I'd add d one more time. So if I start with 15 and I add 3 common differences, that has to get me to 27. So that means the 3 differences, if I subtract 15 from both sides, we'd have to span 12 numbers. Divide both sides by 3 gives me a common difference of 4. Now I'm going to go ahead and add this difference in. If I do 15 plus 4, that gives me 19. 19 plus 4 gives me 23. It's always a good idea to check if I add 4 to 23, does that give me 27? Yes, it does. So I've found those 2 missing terms. They're also called arithmetic means. 19 and 23 are 2 arithmetic means of 15 and 27. All right, on number 8, a geometric sequence has T1 of 3 and R of 2. If T sub n is 96, write out all the terms from T sub 1 through T sub n. Okay, so this was geometric. T sub 1, my first term was 3, so I'm going to write that down. It's a sequence, which means I'm going to have commas between my terms. The next thing it told me was that the common ratio was 2, which means that I'm going to double my term. 3 times 2 gives me 6. Then I have to double that again. 6 times 2 gives me 12. Doubled is 24. Doubled is 48. Doubled is 96. They told me T sub n was 96. That means the nth term is 96. Well, if this was the first term, then the second, third, fourth, fifth, sixth. So question number 9 says, what does n equal in problem 8? N would equal 6 because there's 6 terms in my list. Question number 10 asks me to write the first 7 lines of Pascal's triangle. The first line of Pascal's triangle is just a 1. The second line is also 1s, but there's 2 1s in this line. To get to the third row of Pascal's triangle, like any other row, I'm going to start with 1. Now that I actually have 2 things I can put together, 1 and 1 was 2, and then I end with a 1. To get to the fourth line of Pascal's triangle, I start with a 1. I add 1 plus 2 is 3, 2 plus 1 is 3, and then I end with a 1. The next row starts with a 1 and then a 4. 3 and 3 is 6. 3 and 1 is 4, and I end in a 1. Remember, I'm supposed to have 7 lines, so let's count them. Right now I've got 1 line, 2 lines, 3 lines, 4 lines, 5 lines. That means I need 2 more lines. I need a 6th and a 7th line. Okay, so let's do the 6th line here. Start with a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is also 10. 4 plus 1 is 5, and then I end with a 1. Remember, Pascal's triangle is nice and symmetrical, so if you ever get a pattern that's not the same thing on both sides, you know you've made a mistake. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15 again. 5 plus 1 is 6, and I end with a 1. So this is the 7th row of Pascal's triangle. Number 8 asks me to simplify some things. I have 8 factorial times n plus 1 factorial over 6 factorial times n plus 3 factorial. Remember, 8 factorial means 8 times 7 times 6, and then so on down. I'm going to stop when I get to 6 factorial because down here on the bottom I had 6 factorial. So I look at what I have in terms of numbers. The 8 was bigger, so I needed to break the 8 down until I got a common factorial that I could reduce from the top and bottom. Now I'm going to look at the parts with n's. I have n plus 1 factorial over n plus 3 factorial. I need to think which of those is more, which is more terms. Well, n plus 3 is more terms than n plus 1. So my n plus 1 can be left the same, and my n plus 3 needs to be broken down. N plus 3. If I take away 1 from n plus 3, that's going to be n plus 2. If I take away 1 from n plus 2, that's going to be n plus 1. I could keep doing that forever, but I'm going to stop now because I have an n plus 1 in common on the top and the bottom that I can reduce out. On the top of my fraction, I have 8 times 7, which is 56. On the bottom of my fraction, I have n plus 3 times n plus 2. I would be okay if you stopped here and left it in factored form, but if this were multiple choice and factored form weren't there, technically when we simplify we would have to multiply out the bottom, which would give me n squared plus 5n plus 6 if I FOILed those two things together. So this is another version of the answer. Okay, I've now turned over to the calculator part of this test. Any calculator should work fine. You're really primarily using it for multiplication and stuff. All right, so read the directions. For questions 12 through 17, we have an arithmetic sequence where t sub 1, the first term, is 19, and t sub 2, the second term, is 32. It asks us in question number 12 to find the common difference. The common difference is what you add from one term to get to the next. So 19, add what gives me 32, That would equal 13. So the common difference is 13. Question number 13 asks me to write an explicit and recursive formula for the arithmetic sequence. If I look at my formula sheet, the top formula sheet is an arithmetic explicit formula. So I just need to plug into this formula. The formula is going to start with a sub n equals, because that's what I'm looking for, the nth term. The next thing in my formula says a sub 1. Well, the first term, and this was t's, it doesn't matter, you can use t's or n, t's or a's, sorry. The first term was 19 plus n minus 1. I need to leave n in the formula or it won't be a formula anymore. It will be a specific term. Then we have the last thing in the formula is the common difference, which I found up above was 13. It doesn't specify in this that I have to simplify it, so I could stop right here. Or if I were to simplify that, I would have a sub n is 19 plus, I would distribute the 13, and I'd have 13n minus 13, which I could then simplify some more to write it as 13n plus 6. Okay, to write a recursive formula, I'm going to start out with a sub n plus 1. That means to get to the next term. What am I going to do? I'm going to take a sub n, which is the current term, and I'm going to add 13 to it, which was my common difference. Remember, whenever you write a recursive formula, you also need to include the first term, which was 19 for me. Again, I use a's and the question used t's, but it doesn't really matter, so long as you're consistent. All right, question number 14 says find t sub 300, the 300th term algebraically. Well, if I were doing this recursively, I would have to add 19 over and over and over again, add 13 over and over again until I got to the 300th term. It's going to be easier to use my explicit formula. My explicit formula was a sub n, and I'm looking for the 300th term, so I'm going to plug in a 300 there. Then it was 13 times n, which was 300, plus 6. So now I have 13 times 300 plus 6. So I typed that into my calculator, and that gives me 3,906, which I wrote down as the answer. All right, question number 15 says find n algebraically if t sub n is 77, sorry. So in this case, I know the left side of this formula. So I'm going to plug in 7,377 as the nth term, and then my formula called for 13n plus 6. So I just need to solve this equation. By the way, these things could have been done without a calculator, because so far I haven't really done any heavy-duty math. All right, so I'm doing my 7,000 number minus 6, which would give me 7,371 is equal to 13n. Then I would divide both sides by 13, which gives me 567. So that's my answer. Question number 16 says find S sub 300, the sum of the first 300 terms algebraically using the formula for S sub n. Well, the formula for S sub n is on my formula sheet. I have to recognize that this is the sum formula for an arithmetic series. So I wrote the formula down here. S sub n would be S sub 300, the sum of the first 300 terms. N is the number of terms. So whatever number I have down here, that's the same number that has to go into the formula up there for n. Okay. Then I need the first term. Looking back at the directions for this problem, the first term was 19. Then I'm going to add the nth term. Well, that would be the 300th term for this problem. And if you look up at number 14, we found that answer was 3,906. And I'm taking all of this and I'm dividing it by 2. So this is something I definitely use my calculator for. So I typed that in, making sure to use parentheses, and I got 588,750. So realize if this were going to be on a no calculator part, you could still do this. You would just have to have a little more easy numbers to work with. All right, last one, number 17, find n algebraically if s sub n is 924. So again, we're dealing with the same formula we used up here, except for this time, we know that the answer to the formula is 924. We're looking for n, so this n is going to stay empty. Regardless of how many terms we have, the first term was always 19, so I can fill that in. The next thing I need to fill in my formula is this a sub n up here. I don't know what a sub n is because I don't know how many terms I have. But if I look back up at question 14, I have a formula for how to find a sub n, and that was 13n plus 6. So I'm going to fill in the whole formula for a sub n. All of this was divided by 2. Now I have to solve this for n. I don't like this fraction in there, so the first thing that I would do is I would multiply the 2 over to the left side. And 924 times 2 is 1,848. Then I would combine my 19 and my 6 to give me 25. Then I would distribute my n, because I'm just trying to get this all as one nice little equation. So I see that this here is a quadratic. Let me give myself a little more space. To solve a quadratic, I like to have it equal to 0. So I'm going to rearrange. I like the 13n squared first because I like my squared term first. Then I would put my plus 25n. And then I would move my 1,848 over to the left side by subtracting. So right now, these are some big coefficients. If I wanted to, I could factor it, or I could use the quadratic formula, or I could just use my calculator to solve it. So if I'm going to use my calculator, on my calculator in the Casio, I like to go into the equation menu and go into polynomial, which is F2. If you had your TI, then you could use the polysomult program, and you could go into the polynomial equation there. Or you could just do the quadratic formula or factor. So this is a second degree equation. My A is 13, my B is 25, and my C is negative 1,848. So if I solve this, I can see I have n is equal to either 11 or negative 12.9 something. We know that n has to be a nice number. It's the number of terms that we have. So our answer is going to be n equals 11. I'm going to write the other one down just to say I know I can't do that. And if you had done the quadratic formula, you would have gotten those two answers also. All right, number 18 says to evaluate and simplify 275 factorial over 272 factorial. So most of you, your gut would say to go to your calculator and to type in 275 factorial. Let me go back to the run menu here. 275 factorial. Oh, I need to get a factorial. To do that, I go to Option, and then I hit F6 for more options. I go over to Probability, and it's right there. So the problem is my calculator gives me an error. It can't figure out 275 factorial. That's just too big. And the same thing would happen if you went into this on your TI. So I need to see if I can figure this out another way. Well, 275 factorial over 272 factorial. Which one of those is bigger? The 275 is bigger. So I can break the 275 down. 275 times 274 times 273 times 272. I could keep doing this forever, but I'm going to stop right now because I have 272, which is what I had on the bottom. 272 factorial over 272 factorial would reduce out, and now I'm just going to use my calculator to do the multiplication of these three numbers. So if I do that, I get 20,570,550. And that's the answer to this question. All right, number 19 says to find the 18th term and simplify this binomial. All right, so we know that any term in a binomial expansion is going to have a coefficient out in front, then it's going to have 5 raised to a power, then it's going to have negative 3c raised to a power. So the first thing I've got to do is figure out what's going to go out here in front. I know that whatever power I have, that's the number that's going on the top of this combination. I can also write this as 22c, whatever the next number is going to be. So let's think about what the next number is. When I start out, if I'm using Pascal's triangle or if I'm using combinations, I would have started out with 22, choose none, then 22, choose 1, then 22, choose 2, and so on and so on. So by the time I got up to the 18th term, I would have chosen 17 different times because the first one was 0. So this number down here on the bottom is always 1 less than the number of the term you're on. I also would have started out with no c's in my formula, and they would have been counting up. So this number, the exponent for the negative 3c, is always the same as the number on the bottom of the combination. So that was 22c17. I still have to get an exponent for the 5. I know that I have a total of 22 exponents. I've put 17 exponents with the c, which leaves me with 5 more exponents to put with the 5. I know that my 2 exponents added together always has to equal 22. All right, so now I need to evaluate this. Using either the TI or the Casio, in order to evaluate the 22C17, the first thing I have to do is enter 22. Now I have to get the C. On my Casio, I go to Option, and then I hit F6 for more options, and go to Probability, and there it is, NCR is F3. And then I type the 17. If I wanted to do this on my TI, it's almost the same, except for right here, instead of the Option button, I'm going to hit the Math button. Okay, it's over here on the side, depending which model you have. So you would need to hit the Math button, and then you would need to scroll over until you got to Probability, just like we scrolled over to get to Probability. And then it's probably number 3, it says NCR. But what's on the screen should look similar to what I have on my screen. By the way, if you needed to get the exclamation point, you could get that here as well. So I hit 22C17, and that gives me 26,334. So let me write that down. This was 26,334. Then I need to do 5 to the 5th power, and I could do that on my calculator. 5 to the 5th power is 3,125. And then the last one here, I'm taking this whole negative 3c to the 17th power. So I need to do negative 3 to the 17th on my calculator, which gives me a big number there. That's negative 129,140,163. Make sure you realize that's negative. And then you also had the c. The c was to the 17th power as well. So now I've just got the last part here, which is to put these 3 numbers together. This number is times this number, which is times this number. And all of those have the c to the 17th next to them. So if I do that, my calculator is going to slip into scientific notation. It's 1.0627, and then I don't write EE. I write times 10 to the, and that gives me a 16, and that was c to the 17th. Okay, so some of these problems will slip into scientific notation. That's okay. It doesn't mean it's wrong. When you're taking these numbers with factorials, they get big real quick. All right, question number 20 says, find and simplify the term with an x to the 9th in this expansion. Realize x to the 9th doesn't mean the 9th term. It means the power of x has to be a 9. So in any binomial expansion, we're going to have a coefficient out in front. Then our first thing here is x cubed. That would have to be raised to a power. And then we would need a minus 2y. That would also have to be raised to a power. I know that my exponent is an 8, so that means the top number in my combination is 8. So I'll start out with 8c something. If I knew which term I were looking for, I could figure out what goes on the bottom, but I don't have a specific term number. All I know is that I need my x to be to the 9th power. So first thing I'm going to have to figure out is what goes up here in x's exponent. When you take a power to a power, you multiply the exponents. So that means my x cubed is going to have to be cubed so that I have a total of x to the 9th to get the x to the 9th term. Well, once I know that this number is a 3, I know I have to have a total of 8 exponents, which means I'm going to have 5 exponents left to put to my -2 to the y. Also, once I know this is a 5, that means the bottom number underneath the combination is also a 5, because the number on the bottom of the combination and the number on the top of the second term are always the same. So I have 8c5, which I can use my calculator to get. 8c5 is equal to 56. Next thing I have was x to the 9th, which is just a plain old x to the 9th. Those two things are multiplied. My last term was -2y to the 5th. Realize the -2 is to the 5th and the y is to the 5th. -2 to the 5th power is -32, and then the y was just to the 5th. So now I'm putting these things together. I have to multiply them. 56 times -32 is -1,792. My x was to the 9th and my y was to the 5th. So that is the term with x to the 9th in it. Number 21 asks me to expand and simplify this binomial to the 5th power. By the way, if these were smaller numbers, I could ask you to do a binomial expansion without a calculator, but they would have to be numbers you could get from the Pascal's triangle. So let's work out how we would do that. The easiest way to get our coefficients is probably to just start out listing Pascal's triangle. And I know to get each row of Pascal's triangle, I add together the two terms above to get the next term. If my power is a 5, I need the row that starts with a 1, 5 in Pascal's triangle. So my coefficients are going to be 1, 5, 10, 10, 5, 1. So I would list them out. 1, 10, whoops, I forgot the 5. Let me re-say that. 1, 5, 10, 10, 5, and 1. Then each term is going to have a 3 to a certain power. I'm going to start out, and in my first term, I'm going to put all 5 exponents with the 3. Then I'm going to drop down to 4. Then I drop down to 3. Then I drop down to 2. Then I drop down to 1, and in my last, I don't have any of those 3's. Next, I have a 2b. I have to be careful if this is negative. I need to put that in if it's subtraction, but this one isn't. So I'm going to start out with no 2b's. Then I'm going to have 1 2b. Then I'm going to have 2 2b's. Then I'll have 3 2b's and 4 2b's. And my final term will get all 5 of the 2b's. Last, I just need to put these things together. So I have 1 times 3 to the 5th. Well, 3 to the 5th is 243. And then my 2b is to the 0 power. Anything to the 0 power is 1. So this first term is just 243. Then there was an addition sign to get to the next term. For the next term, I have 5 times 3 to the 4th power times 2. If I do that in my calculator, it gives me 810. And I have just b to the 1st power, so a single b. For my next term, I have 10 times 3 to the 3rd power times 2 to the 2nd power. Make sure you don't forget to raise that 2 to the 2nd power. If I put that in my calculator, that would give me 1080, and that b would be squared for that one. For my next term, I have 10 times 3 squared times 2 to the 3rd power. So 10 times 3 squared times 2 to the 3rd power, if I put that in my calculator, is 720. So I have 720, and their b was cubed on that one. For my next term, 5 times 3 to the 1st power, so I can just do times 3, and then times 2 to the 4th power. If I put it in my calculator, 5 times 3 times 2 to the 4th is 240. And that was b to the 4th power. On my last term, I have 1 times 3 to the 0. Well, 3 to the 0 will just be 1. And then I have that times 2 to the 5th, which is 32, b to the 5th. I cannot add any of these things together because none of them are like terms. They all have a different amount of b's. But I need that whole big expansion for number 21. Question number 22 says, assume that this year, n equals 1, the average annual salary for women in the United States is $45,000 and that it is increasing by 5% per year. Question A says, write the first three terms of the sequence of salaries. So A sub 1, the first year is right now, that would be $45,000. A sub 2 at the second year, well, we have to increase by 5% per year. So if I'm increasing by 5% per year, that means I need 105% of what I used to be. So the number that I'm going to multiply by is 1.05. If I do 45,000 times 1.05 on my calculator, that will give me $47,250. To get my third year, again, I'm going to multiply that by 1.05 because I have to increase by another 5%. If I take my 47,250 times 1.05, that gives me $49,612.50. So those are the first three terms of my sequence of salaries. Part B asks, what type of sequence is this? And we should recognize, since we're always multiplying by the same number, that this is a geometric sequence with a common ratio of 1.05. Question number 22C. Now we're moving on to assume that this year, n equals 1, the average annual salary for men is $60,000 per year, and that it is increasing by $2,000 per year. So this is also a steady rate of increase, but it's just increasing addition by $2,000 per year. So my first term for this one would be $60,000. Then we would add 2,000 to that. So my second year here would be 62,000. And then we would add it again, and my next year would be 64,000. In this one, I added the same number each time. So that makes this arithmetic with a common difference of $2,000. Part E says, who will be making more, women or men, in the year n equals 27? Well, I'm going to have to figure this out, how much each person would be making. I'm going to call them W sub 27 and M sub 27 to separate the men and the women, even though I called them both A's before. So for the women, they were geometric. And the formula for geometric is A sub n is A sub 1 times r to the n minus 1. And up here was the formula for arithmetic, which is the one we'll use for the men. So I wrote those two formulas down on this page. If I'm looking for the 27th term of the women's sequence, the first term was 45,000. The common ratio was 1.05 because that's what I multiplied by every time. And then I would need to repeat that process 26 times because to get the first number I didn't multiply by the common ratio at all. All right, so that I could type into my calculator. And when I do that, it's going to give me $160,005.27. All right, let's check on the men. Well, the men started, their first term was 60,000. Then I'm going to repeat this process 26 times because n minus 1, 27 minus 1 would be 26, and their common difference was 2,000. So if I do that on my calculator, 60,000 plus 26 times 2,000, the men are then making $112,000. So who is making more? It looks like the women are. In general, geometric series are exponential, and we know exponential functions can grow much faster than linear ones. How much more? Well, that would be the difference between the two. So if I take my 160,000 that the women are making, and I subtract my 112,000 that the men are making, that will give me $48,005.27 more. You can expect a real-life application to show up on your test. It's not going to be the same real-life application that was on the sample, because the whole point of the real life is that you have to make a new situation and be able to apply what you know. Question number 23 through 29 involves a geometric sequence with a first term of 100 and a second term of 90. So they ask us in 23 to find the common ratio. This means 100 times what gives us 90. If you're not so good with figuring that out when they're fractional amounts, just write it out algebraically. 100 times the common ratio has to equal 90. So we divide both sides by 100, and we can tell that our common ratio is 9/10. I prefer leaving my common ratios as a fraction, but you could also write it as a decimal of 0.9. Either one is fine. All right, number 24 asks us to write an explicit and a recursive formula for the geometric sequence. From our formula sheet, the formula for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. That's an explicit formula. So I start with my a sub n. I can fill in a sub 1, my first term. My first term would be 100. My common ratio, again, I like to leave it as 9/10, but you could put it as 0.9 if you prefer. And then in order to leave this a formula, we need to leave our n minus 1 in the exponent so that I can show I have an n variable to plug in. To find a recursive formula, I start out with a sub n plus 1, meaning to get the next term, what am I going to do? Well, I'm going to take a sub n, the term I have right now, and I'm going to multiply it by 9/10. So I also could have written this as 9/10 or 0.9 times a sub n. Doesn't really matter to me which way you write it. Whenever I write a recursive formula, I also have to say what is the first term, and my first term was 100. Again, in this one, I used a's instead of t's. It doesn't really make a difference. Question number 25 says find t sub 30, the 30th term algebraically. Well, if I'm going to find 30 terms, it would be easier for me to use an explicit formula. That way I can just plug in 30 for n. So I have 100 times 9/10 to the 30 minus 1. If you're going to type this into your calculator, I recommend you do the subtraction in your head. You can call it 0.9 or 9/10, doesn't matter, but call it 29th power. If you are going to type it in with the minus 1 in your calculator, be sure that you put parentheses around that so you don't accidentally take it to the 30th power and then subtract 1 from your answer. So typing into our calculator, 100 times 0.9 to the 29th power is 4.7101. I went ahead and truncated this to 4 places after the decimal because that's the accuracy that we like in the directions on this test. Question 26 says to find n if t sub n is 28.2429. Now, I've given you these decimals in the end. That means that I'm truncating. So you might not get exactly a value for n, but we should be able to round it appropriately, and it should be very close to a whole number. So in this one, I know t sub n, which is the left side of my formula. And I have the formula written down above. The nth term I just filled in would be equal to 100 times 0.9 to the n minus 1 power. So I've got to solve this equation. To solve this equation, the first thing I need to do is to move the 100 over to the other side. So I'm going to divide both sides by 100. So that would give me 0.28249 is equal to 0.9 to the n minus 1. Now in this equation, I have an n in the exponent. How do I get the n out of the exponent? It's an exponential equation. I'm going to log both sides. So I would take the natural log of both sides here. The reason I like to do that, let me fill this out so far. Oops, I left a 2 out of there. Sorry. The reason I like to do that is because now I can take the exponent and pull it out in front of the log. Okay, now I need to get the n by itself. So at this point, I would probably move the ln over to the other side. So I'm going to divide both sides by the ln of 0.9. You also could have distributed here, by the way. Since I didn't distribute, the last thing I have to do to move this over would be to add 1 to both sides. So my final answer for this would be the ln of 0.28249 over the ln of 0.9, then add 1 to that. If I type that stuff into my calculator, make sure again that you close parentheses if you're using your TI around your natural logs. That would give me 13.0000, so I can tell 13 is the number of terms. I could also go back and I could find the terms individually using the recursive formula on my calculator just to verify that this checks out, and that should work. All right, question number 27 says find S sub 3 algebraically using the formula. So we need the formula for the sum of the first n terms of a geometric series. And on our formula sheet, we can tell that's the sum formula that had r's in it to indicate it was geometric. So for this one, I'm plugging in my n, my number of terms is 3. So S sub 3, the sum of the first 3 terms. A sub 1 is the first term. The first term in this one for me, if I look back up at the top, was 100. Then I have 1 minus my common ratio. For this one, I'd probably use 0.9 because I'd rather type a decimal into my calculator. And that's to the third power. And all of this is divided by 1 minus my 0.9. All right, so the biggest problem you guys have with this is honestly typing it into your calculator. So I would recommend you don't try to do order of operations on your calculator. Just type it in exactly like it's written, making sure that you put parentheses down here around the bottom. Also, if you're typing in a fraction, be sure you put parentheses around the fraction that you're typing in. Let me show you what that would look like. So you can see that either method I used there, the 0.9 or the 9/10 as a fraction, gave me 271 for my sum. So that equals 271. The other thing I will caution you, it says find it algebraically using the formula. So you have to actually show that you would plug into the formula, but with only 3 terms, it would be easy enough to find those 3 terms by hand and add them up just to check your answer. Question number 28 is still dealing with the same sequence, and in this case, we're trying to figure out what n is if S sub n is this 972 number. So again, let me write out my formula for the sum of the first n terms. And that was on my formula sheet. So in this case, I know S sub n, the left side of the formula, was 972. And I've got this big long decimal over here. That just means it's a truncated answer. So I might get, slightly off on my n, but I should be close. So the first term was 100. 1 minus my common ratio. Again, I'm going to use 0.9. I do not know what n is, and that's over 1 minus 0.9. So if I'm going to solve this equation algebraically, the first thing that I would probably do is this 1 minus 0.9 down here on the bottom, which is 0.1. So the next thing that I would probably do is I would do the 100 divided by the 0.1, which would give me 1,000. Now, notice I did not try to do the 1 minus 0.9. I couldn't do that part yet because the 0.9 was raised to the nth power. So I can't combine those things inside and call that 0.1 to the nth power. That doesn't work. All right, so the next thing that I would do is I would want to divide both sides by the 1,000. And when I divide by 1,000, that's going to give me 0.97218711611 is equal to 1 minus 0.9 to the nth power. Then I would subtract 1 from both sides to move that over. If I subtract 1, that would give me negative 0.0278. There's a bunch more decimals in my calculator, but I'm not going to write them down right now. Just be sure you use the answer button on your calculator for the next steps. Now, since I had a negative on both sides, I would just switch that to positive. Then I'm going to take the log of both sides. So now I have the natural log of this 0.02 number on my calculator. I can bring the n out in front of the natural log of 0.9. And then I would divide my natural log of 0.9 to move that over. So n is the natural log of the 0.02 number divided by the natural log of 0.9. And if I type that into my calculator, I get 34.000. So I'm just going to call that 34. And I know I should get a nice natural number because I have to have a specific number n of terms, not a nice decimal number. Question number 29 says, as n gets very large, by that I mean n is going to infinity. It's getting very, very large. It says, does s sub n converge or diverge? Well, converge means comes together to a finite number and have a particular sum, or diverge means to go off and not fit into a category. If you're divergent, you go off and don't fit into a category, and that means that you would not have a sum. So in order to have a sum to infinity, we have to be geometric with a common ratio between -1 and 1. And our common ratio was 9/10 or 0.9. So that would mean that this thing is going to converge. It will have a finite sum. How do we know? We know because it's geometric, where r, the absolute value, is less than 1. Part C says, find what number s sub n approaches as n gets very large. If I look over on my formula sheet, I have the formula for an infinite sum. It involves the limit as n approaches infinity of s sub n. That just means s sub infinity, right? The sum of an infinite number of terms. And then over here on the right, I have the first term divided by 1 minus the common ratio. So for us, the first term is 100. We had 1 minus 0.9, so that's 100 divided by 0.1. If I'm going to use my calculator, just be sure to put that in parentheses, which would give me 1,000. So the sum of all the terms through infinity is 1,000. There will be a sum, even though if I kept adding terms, I'd never actually get there. All right, question number 30 says, find the coefficient of the term that contains x to the first power in this binomial expansion. So in any binomial expansion, I'm going to have a combination out in front where the top number of the combination is the exponent. Next, I'm going to have the first term to a power, and then I'll have the second term, which in this case I need to keep the negative with that second term, and that's going to be to a power. I know that whatever exponent I have here plus whatever exponent I have here, those two together have to add up to give me 9 because that was my total number of exponents. Now the weird thing about this one is I need x to be to the first power. If your instinct tells you to throw a 1 in here, just be careful. This would mean I would have an 8 over there, so I'd have 3x to the first power over -2. So that would be times, I guess, -2 to the 8th power. And then this x would be x to the 3rd to the 8th, which would be power to a power you multiply, x to the 24th. I'd still have my coefficient out in front here, but you can see I have way too many x's on the bottom to simplify to x to the first power. So this is not going to work. We could just sort of logic our way and guess and check through this. I can tell I have many more exponents on the bottom. So I'm going to have a smaller power here than I'll have to have over here. So if I'm totaling up to an exponent of 9, let's just make a guess. What's going to happen if I put 8 powers here and only 1 power there? Well, that would give me x to the 8th over x to the 3rd, which is going to reduce to x to the 5th. Oh, I'm sorry, I needed x to the 1st. That's too many exponents on top, so I need to make this first number smaller. So what happens if I take it down by 1? What if I make that a 7? And this would then be a 2 to total to 9. So what do I have now? That means I have x to the 7th for my A term. I would have x to the 6th for my B term when I do a power to a power, and that would reduce to x to the 1st. So this means my numbers I need for my exponents are the 7 and the 2. Remember, whatever I put in this place, that's what has to go on the bottom of my combinations. So I'm going to have 9c2, which I can do in my calculator. 9c2 is 36. I'm going to have 3x to the 7th power. So I need to do the 3 to the 7th in my calculator is 2,187. And then the x was also to the 7th. For my last fractional term, I have negative 2 squared would be positive 4, and then I have x cubed squared, which would be x to the 6th. So if I multiply this stuff out, I have 36 times 2,187 times 4, which gives me 314,928. And then for my x's, I have 7 x's on the top and 6 on the bottom, which reduce to x to the 1st power. The directions said find the coefficient, so technically that's just the number part. All right, so come into class with any questions that you have, and make sure that any of these problems could have been on the calculator or the no calculator part of the test. The difference will be how difficult the arithmetic is, but all of the concepts should be able to be done without a calculator.